Hey everyone. Today I'll be talking about the migration journey from Amazon DynamoDB to Yugabyte YSQL and Hasura. And my name is Tobias Meixner. And let's look at the agenda today for my talk. First of all, I will give a brief introduction to BRIKL and the use case that we have on hand from BRIKL. And then we will dive into DynamoDB. So we're using DynamoDB today, and we will look at how we are using DynamoDB at BRIKL. And as a next step, we will go into Yugabyte and Hasura. So how do we migrate from DynamoDB to Yugabyte and Hasura? And the last part is pretty much looking into the migration path that we have taken and the approach on migrating over. And before we dive into the talk, just a quick introduction of myself. German, born in Berlin, pretty much started from the beginning with computers early on. Also, fun fact, I've been an ice-speed skater in the early days before I started studying and working. And as of today, I'm a co-founder and CTO at BRIKL. I will talk a bit more about BRIKL right after this. And technologies I'm excited about is AWS. I'm also a certified solution architect. I really obsessed, I would say, about GraphQL, really involved also in the community in GraphQL, and I do like serverless. And that's a quick introduction of myself. And let's dive into the talk. So talking about the migration journey for BRIKL, I just want to give an introduction about what is BRIKL about. So BRIKL is a next generation 3D configurator. And you can see some impression of the 3D configurator here on the right-hand side. And let me tell you a bit more about what we do. We help brands, retailers, and manufacturers alike to sell custom products online. And that's mostly sports wear these days, which can be also promotion wear or pretty much like sports equipment that is made available for universities, sports clubs, and so on. Then let's jump right into the data model. So we do have an e-commerce platform, and if you're familiar with the e-commerce, then you probably know the common data models or tables that you have in e-commerce. So I will not go into detail, but in general, we do have the e-commerce modules, which is products, collections, variants of products, and product attributes. We do also have a specific data for the custom products that we're offering. So the design studio, which is designs. We do have design templates. We have placeholders, materials, and colors. And then, of course, we also have configuration. So we're actually a multi-tenant system, meaning we offer this system as a white labeled solution to our customers. And that, of course, requires a number of configurations that need to be made for each of the customers. And alongside that, we also have the e-commerce part in general that we need. And on top of that, we also have, of course, payment and shipping, notifications like webhook configuration and so on. And we do also offer our own CMS solution. So we also have an endpoint for the content. And that is the data model that we have on hand for BRIKL's use case. And how does that look like? If you're familiar with GraphQL, you may know GraphQL Voyager. And GraphQL Voyager kind of shows you the schema in GraphQL as a data model. And that's pretty much what BRIKL looks like today. We have 288 types, 111 enums. We have also a number of input types that we use for our mutations. And we have 3 custom directives, which I explain in the next slide. So we're using Amazon DynamoDB with GraphQL. And before I explain about more how we use it, I just want to talk about Amazon DynamoDB in general. There's a nice blog article from Yugabyte actually about the strengths and weaknesses of DynamoDB. And you can just have a look at this blog article, but in general, if you worked with DynamoDB before, you will know it's a NoSQL database. So what it means automatically normally is that you're quite flexible in terms of data modeling. And DynamoDB itself is also very easy to maintain because most of it is taken care of by Amazon. So it's really a fully managed database that gives you the peace of mind working with DynamoDB. And of course, since it's an Amazon product, it's also well integrated with AWS services. So things like S3 or other services are pretty easy to be linked together with DynamoDB. Then, of course, there's a number of challenges that you will run into when you work with DynamoDB, which you may not notice in the beginning, but only after you get started. And biggest problem probably is the consistency, and then also the developer experience. In terms of consistency, you will always have trouble with DynamoDB. So you will have to manage that from the coding side, how you want to manage the consistency. And I think it requires quite some extra efforts to make this happen. But really the biggest pain point, I think, for DynamoDB is developer experience, which is great in the beginning once you get started, but which is very, very challenging after you scale your team or you have people on the team with a different background. Let's say they have no experience with NoSQL, or they have worked with another NoSQL database before, like MongoDB. They will still have trouble to understand or to kind of get into DynamoDB. So there's quite a high learning curve and also quite some quirks inside DynamoDB that you may run into. And yeah, it's pretty much figuring it out over time working with DynamoDB. So that can be a challenge as a company. So let's look how we use DynamoDB at BRIKL. I mentioned that we use GraphQL and that we have directives. So if you're familiar with GraphQL, there's a common approach, which is schema first. Schema first means you will define your GraphQL schema by default, and that defines it as a static string. So you define your schema, and which has no definition of, let's say, the data model. It's pretty much separated from it. Which can be a problem. So sometimes you wish to have some sort of custom solution or custom directives where you want to extend the capabilities of a GraphQL schema. And if you use schema first, many times you will also want to use schema directives. So if you're familiar maybe with AppSync, you will know they also have custom directives where you can then extend the functionality of your GraphQL schema and give them additional logic on top of it, which can be a function or related to the resolver that you have in GraphQL. And that is pretty much also how we link our GraphQL schema to DynamoDB. So we don't have any ORM, actually. We just use directives to kind of map the GraphQL schema into DynamoDB. And how that works is we have a custom directive, which we have created, which has a bunch of parameters that you normally use with DynamoDB. So you will have to define the table name, you will have to define the hash key, you might have a range key as well, and then a bunch of filters or indexes that you have defined in DynamoDB. And if we take the example of leads, so if we want to get the leads out of our database, in our case, what we have is we are querying by an index, which is in our case this index, and we query by the hash key, which is lead. So we want to get all the leads with this type name, and our hash in this case is the field type name, and that is kind of how we are mapping the data today from GraphQL to DynamoDB, which has a great developer experience, but also some challenges which I will get into. And Getting data out of DynamoDB is always a combination of an index, probably a type if you have single table design, and then hash and range key, how you want to query your data performantly. So to use DynamoDB, a common scheme to use it in a, let's say, approach is single table design. And single table design sort of looks like this, right? You have a very, very long, very, very big table which stores all of your data. And that can be, on the one side, great because you have just one table to refer to, but it is really challenging in terms of data modeling. So even for SQL, you have to think a lot about data modeling as well. But for DynamoDB, it's even more complicated because it's not really natural. It requires quite some experience to do the modeling properly in a single table design. And many times what you're going to have is you will have a type name. So anything that you store on the table, you will want to identify what kind of type or what kind of object that is that you're storing. And most of the time you will also have a UUID as a hash key. So you can shard your data across different partitions properly. And many times then you will require a range key. And a range key is basically the secondary key for DynamoDB to sort data. But not only to sort data, but also to filter data. But many times when you have a single table design, you will also run into issues adding more range keys. And those range keys will be normally a concatenation of different fields. So you will combine different fields that you then use to access different rows. And how does that look like normally? It's going to be like this. So this is an example from BRIKL. If we take a product, so the primary key in our case is going to be the product ID, our UUID. And then we do have different type names. So we might have relational data. So for example, we have assigned attributes to a product. We also have product option values, for example, we have product variants, and we have the product itself. And the way we go about this in DynamoDB, one way is just to use the secondary key here, the sorting key, with different attributes. And in our case, for example, with details, we are getting the actual product. And then any other type related to a product might have a different sorting key. So they are all stored in the same partition, which may be performant to query everything related to that product at once by one primary ID. And then the secondary ID can be quite cryptic. If you combine different fields into a secondary key, it might get fairly complicated. If you combine, let's say, 3 or 4 fields into one, it is not a nice developer experience because they will have to figure out how the data is stored for each of the single use case that you have. And the solution to support more use cases is then many times more indexes. More indexes may be great in the SQL world, but in terms of DynamoDB, that just means more data and also more cost as a result. So it can be really challenging for you to foresee all the use cases in the beginning. So even you have, let's say, 2 or 3 indexes defined for your data access patterns. In the end, you will always end up with more indexes over time. And that is, of course, not an approach that you want to take. So that is also kind of the situation where we ended up in BRIKL, is where we step by step had to define more indexes. There's a way to use sparse indexes where you can only have certain fields defined per object that you want to query. So that means only the indexes are filled with the data that you actually want to query. But in the end, many times probably you will run into issues where you're just going to have too many indexes with too much data, which then results into more cost. So what to do now? If you end up with the notion that DynamoDB is not the solution for you anymore. For our use case in BRIKL, the requirements to change were mostly developer experience. So we were struggling to kind of explain also to new developers how our data model works. And so for us, very important was to get a nice developer experience. And then we also wanted to have flexible and performant queries, which can be also very challenging in DynamoDB. We also use global replication today in DynamoDB with global tables, so that is the same that we still want for the new solution. We want a highly scalable solution, of course, and in best case, it is no code and no ops, which of course is most of the times better and easier to maintain. And that is how we found Yugabyte. So Yugabyte pretty much covers what we were looking for. So this is global data distribution is very important to us as an e-commerce provider. We do want to have data very close to the customer, where latency and the storing of the data is very important in terms of the location. Also, we were not happy with the transactions offered by DynamoDB. The same for the global replication, which can cause issues. So we do like the approach of Yugabyte in this case. And also, in general, Yugabyte can be scaled very well. And that's sort of not a big switch from DynamoDB to Yugabyte. We see the value in the solution. And also, of course, the multi-cloud approach and availability for Yugabyte, it has also a lot of benefits for us in the future. And since we use GraphQL, we also look for a solution that, of course, helps us to kind of map what we have today to be used in GraphQL. And when we learned that Yugabyte and Hasura play well together, we liked it even more, of course. So we do like the approach of having a Hasura instance that then kind of connects to a different node in a different region, for example, for Yugabyte. And also kind of the vision of Yugabyte for taking care of the connection pooling together with Hasura, where you can then decide to kind of which node you're gonna connect to automatically. Really sounds good to us in terms of operations. This must be a great solution. So let's look at the results, what we have in terms of our requirements that we had and what we get with Hasura and Yugabyte. So in terms of developer experience, I will get into detail after this. But we do get flexible and performant queries out of the box with Hasura, which is great for our API layer. We do have global replication. We have a highly scalable solution with Yugabyte DB. And no ops, I will also get into that later. And then what we also get on top with Yugabyte and Hasura together, we get GraphQL out of the box. So before we've been using Apollo server and kind of taking care of most of the GraphQL stuff ourselves, meaning writing custom resolvers and defining the schema by ourselves, which we get out of the box with Hasura, which is great. And we do have GraphQL best practices built in also in Hasura. So things like data loading and other issues you may have in GraphQL, that is automatically solved with Hasura. So this is good news. So let's dive into the migration. How did we go about the migration from DynamoDB to Yugabyte? So going from DynamoDB, a NoSQL database, to Postgres can be challenging. Why? Because there's probably no best practice because it always depends on your use case and the way you store data in NoSQL. Because NoSQL is so flexible in terms of data modeling and data storing, also depending not only if you use DynamoDB, but maybe another NoSQL database. There's really no right or wrong way. In general, the good news is you can take the advantage of going from NoSQL to SQL by, let's say, stronger typing. So it's not only adding a, let's say, type name into NoSQL like before, but now you can actually map your, let's say, relations and your types to a table. And that, of course, helps automatically already for yourself to kind of structure your data in a better way. And many times the migration path, probably going from NoSQL to Postgres, is remodeling, which is essentially re-architecting, meaning most likely you will have to do changes in your code as well to kind of get to the point where you can replace your application layer as well to connect to the new database, because things will most likely work differently. If we take, for example, ETL, which is many times required to run a NoSQL database where you want to kind of prepare and transform your data in the shape that you want. But maybe in SQL, you just have that out of the box, so you don't have to have those ETL scripts anymore. And yeah, a lot of common tasks that you will have to do is essentially you will have to find out duplicate records. You will have to do data mapping from NoSQL to SQL. You will have to look into how you want to kind of translate your data and try to do a migration run. What is great in terms of Postgres, of course, is then sometimes you will have the ability to just take what you have in NoSQL and store it as a JSON in Postgres. And if that is a good option for you, then probably that's the way to go for you to, let's say, if you have some time constraints, then probably you might just want to dump your data from NoSQL into a JSON field in Postgres, if that is just the way to go to move over your data for some of the tables maybe. Of course, this can't be a generic solution, but it can be a good solution for some of your cases. And then moving on, how can you migrate from DynamoDB in a more technical sense? So there's DynamoDB streams available. So you can actually listen to any kind of update in DynamoDB, meaning you can just take the updates or creates or deletes in your database and then directly stream that into your new database, which can be a great way if you want to have some sort of a live stream to your new database, just in terms of testing or in terms of looking how the data will look like in your new database. There's also AWS data pipeline, which I find very having a very steep learning curve. So it's a great tool, but it's a very very complicated. So many times what you will end up using is custom scripts. So you will have a Lambda function or some sort of script or host it on EC2, where you then connect to DynamoDB and do the actual migration as a, let's say, one-off script that does all those data mappings and translations, and transformations, anything that you need, and do that for you as a custom script. So there's no real solution out there yet. So what did we do at BRIKL? At BRIKL, we started from scratch, meaning we re-architect, because we also had some, of course, technical debt in our Apollo server, for example, where we just decided we will start from scratch, meaning we were also replacing our application layer with a new application layer that we built totally from scratch. And of course, we take the advantage also of cleaning up our data. So anything that is deprecated in our GraphQL schema or the fields in our database can be just automatically deprecated and removed. And also, as of today, we have a monolith. So we also decided to take the advantage to kind of split service by service. And we also had the decision to kind of go with the less critical services first, of course, meaning that we take the content service that we have, which is fairly small and fairly simple, to take that as a first service to be migrated. And then the way to go about the migration on the client side is essentially pointing to a new API. So we have a GraphQL API today, and based on a feature flag, we will then point, depending on the field and depending on the use case, to the new API step by step. And that is just done by a feature flag. So we just toggle that and to kind of try out or test the new API pointing to Postgres. And to do the data migration itself with DynamoDB is actually fairly simple. You can do a DynamoDB full table scan, which just gives you all the data. If you have a single table design, that is even easier. So you just connect to one table, and then you will have to do an import, of course. And for us, that is a bulk import of all the existing data, which is also great if you do a bulk import just to see kind of the load testing and performance testing that you can do beforehand. And then once you go live, you will do a re-import. So you could either do just importing everything again, depending on your size of your data, or you might just do a delta. So you're looking at the updated add or created add fields, and then import that missing data over and then point to the new database. And that is the approach that we have taken. And one of the things that I mentioned that important to us was developer experience. So we want to have all members on the team to perform at their level best. And developer experience is really important to us. And that's why we also decided to invest a bit more into tooling. So having worked with Yugabyte and Hasura together as a solution, we noticed that we're missing some things. For us, we decided to combine Hasura and Yugabyte also with Prisma, which all three play very well together. And what we end up with is essentially this model where you have Hasura as an API layer, where you have mutations defined as actions in Hasura, and which then are used in the service layer. So for each service that we have, we then have a data layer, which is using the Prisma client. And the Prisma client is essentially our source of truth for the data. And then queries, of course, going through the API layer, go directly through Hasura in our case. So we are using the Hasura queries that come out of the box because they are quite powerful in terms of filtering pagination, which you all get out of the box with no code whatsoever, and which then directly connects to Yugabyte. And our approach on moving from Prisma to Hasura is defining the Prisma schema in a Prisma file, and then generate out of that the Hasura metadata with all the tables, actions, relationships, permissions, and anything that you need, not only for Hasura, but also, let's say, if you have an API layer. And how does that look like? If we jump into the code here, that is an example of our Prisma schema. That means we have our models defined in Prisma, and we can take advantage of some of the features that we have with Prisma, which is like defining IDs, defining default fields, these kind of things that we use out of the box from Prisma. But we also have, you will see that here, is meta fields. So many of our fields that we have in NoSQL today, we're actually moving them into meta fields. Why? Maybe you're familiar with the Stripe API, for example. So many, I guess many applications or many services that you use today may be using Stripe. And they're using actually the meta fields in Stripe, which are very powerful because you can actually put any field or any kind of key value you can put into meta fields. And that's sort of the same approach that we also have, having in mind that we might want to have third-party applications or just any kind of logic that we want to have in the future. We will put them in a JSON field and use that as a meta field for each model that we have. And that can be quite powerful, of course. And then going from Prisma schema to Hasura. we said we define our mutations in GraphQL. So this is pretty similar to before, where we just have some certain extensions that we have built in terms of GraphQL. This is what we can use to then expose them as mutations in Hasura. And then as a third step, we have the Hasura metadata. So we will want to go from each service that has its actions. We will want to expose that as an API. So what we have built is a small tool that kind of takes the Prisma schema, takes the actions, and then links them to the Hasura metadata, which is then also generated for us with just a little bit of code. Instead of using the Hasura UI directly, we have that all generated. And that's a great developer experience that we are looking for, because this is essentially also very useful when you have multiple services. And that is how we use Postgres today with Hasura, with Yugabyte, and also with Prisma to help us to model the data. And that was all. I will be available after the talk and happy to answer all of your questions. Thank you.